Hi, in this lesson, I'm going to briefly go over some properties of exponents. I'm going to start with some really basic properties, and then we'll get into some of the more difficult to understand, but really not so difficult properties. To show you the property rules, they're just properties, but to show you the rules, I'm going to show you how to do it the long way first so that you understand where the property comes from. So if I have x squared times x to the fifth, what that means is that x is being multiplied 2 times. So the exponent is indicating how many times the base is being multiplied. And then I have x to the fifth, that means 1, 2, 3, 4, 5. Now, if I recondense this, I don't know if that's a word, but we'll go with it. If I recondense this using the rules of exponents, that if something is being multiplied, if the same number, the same component is being multiplied, then I can condense that into an exponent. So here I have x is being multiplied how many times? 7. So I can just condense that to x to the 7th. Now, if I do this one here, x to the 6th, 1, 2, 3, 4, 5, 6, over or divided by x squared, then I have some simplification I can do here. These x's divide and these x's divide. Well, you can pick any x, but I just picked the first two. And I'm left with x being multiplied by itself how many times? 4 times. So that's x to the 4th. And then this last one, it has 3x to the 5th squared. So by definition, that means 3x to the 5th times 3x to the 5th. The base is 3x to the 5th. It's being multiplied twice. And then if I expand it even further, I have 3 times 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have x times x times x and so on, 5 of those. And then I'm just multiplying now, and I'm going to use the commutative property. So I'm going to change this to 3 times 3. And then x to the 5th, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Goodness, that's a lot. And then recondense it. 3 times 3 is 9. And I have a total of x to the 10th. Okay, so maybe you were seeing some patterns as I was going, but let's back up a little bit. So let's go to this first one. I've shown you the long way, and the long way obviously works, but you can see that it might get a little bit, you might get a little bit tired of writing out x's so many times, especially if it's like x to the 100th. That's ridiculous. So we don't really want to have to do this over and over and over again. So what do you notice here that happened? If I have x squared times x to the 5th, I ended up with x to the 7th. How can I go quickly from this step to this step? What's happening to the x's? I'm totaling them up. So if I have two components being multiplied with the same base, I'm actually adding all the possible x's. So two components being multiplied with the same base, I can simplify that by adding the exponents. Multiplication, same base, add exponents. And that's all. It's a little bit faster. So if you have x to the 100th times x to the 200th, instead of writing that out 300 times, you just add the exponents and you know there's going to be 300 of them. Now for division, it was a little bit different because I had x's that divided to 1. So they don't really, because it's a 1, but they kind of disappear. They subtract out. So I end up with x to the 4th. And we know that 6 minus 2 is 4. So when you have division, we're actually subtracting the exponents because we had certain exponent or certain components that divided to 1, and it kind of subtracts them out of the expression, and we end up with subtraction. How did I write that? Subtract exponents. So we're really just adding and subtracting, which is not very hard. And then this last one, when I had a power to a power, I did throw in this 3 because there's some common misconceptions there, and I wanted to show that the long way because oftentimes people want to do 3 times 2, but that's not what's happening. 3 is being multiplied by itself. 3 is being multiplied twice. So we end up with 3 times 3, which is 3 squared, which is 9. So what's happening here is I am actually squaring the 3. The 3 is a number component, it's a coefficient, and I am actually squaring it. 3 squared is 9. But I did not get 5 squared here. I got 10. 5 squared is 25. So what happened there? What happened when I had x to the 5th squared? I didn't square the 5. What did I do? X to the 5th squared means x to the 5th times x to the 5th. And we know that when we multiply components, we're actually adding. So you have to be very careful there. When you have a power to a power means multiply. 5 times 2 is 10. But you have to be very careful with the coefficient. I'm not multiplying 3 times 2. I'm actually doing 3 squared. So that's the only really tedious part of this one. Simply put, power to a power means multiply. But you have to be careful if there's a coefficient, you are actually squaring that or cubing that or whatever. So I usually call this power to a power means multiply. And if you're unsure, just write it out the long way, expand it out the long way, and you'll see where that comes from. So now that we know the rules, let's do these using the rules. Try not to expand it out. Try to do it the short way, using the properties. So pause it, try all these, come back and check your work. The first one was pretty straightforward. I did use the commutative property. You don't have to use the commutative property here. You can just, if you see the x's and you see the y's in your head and you join those together, that's totally fine. I just wanted to go ahead and expand this out as much as possible for note-taking purposes and teaching purposes. So I did move the x's to be together and I did move the y's to be together. And then with the x's, I used my property where I'm adding the exponents and I get x to the 7th. And for the y's, same thing, I'm adding the exponents and I get y to the 12th. So you have x to the 7th, y to the 12th, and that's all. To the right over here, again, I used the commutative property and I joined the like components. So I joined the 2 times 5. Remember, this is all multiplication. I have some different symbols being used here with the parentheses and then just the side by side, but it is all multiplication. So I have 2 times 5, and then I have x squared and x to the 3rd, and then I have y to the 1st, y to the 8th. And then I worked on each component. 2 times 5 is 10. And then with the x's, I'm going to add those exponents to get 5. And with the y's, I'm going to add those exponents to get 9. So you have 10 times x to the 5th times y to the 9th. And that's all. Next one, we have some division here. We know that division translates to subtraction. So I have the a's, a to the 5th minus 1, and then the b's, b to the 7th minus 5. And that gives a to the 4th times b squared. And that's all. You can break that up differently if you want to. I didn't do that. Oh, whoa. Okay. You can group the a's if you wanted to. A to the 5th, a to the 1st, and then the b's if you wanted to. And then go to that step, that's fine. But if you skip right to the next step, as long as you got the same answer, you're good. And then the last one was just a little bit more involved here. We had that power to a power thing going on. So what we actually have here is 2a to the 3rd to the 3rd. And that means 2a to the 3rd times 2a to the 3rd times 2a to the 3rd, which translates into 2 to the 3rd, because 2 is being multiplied 3 times. And then a to the third, because a to the third is also being multiplied 3 times. And then here, 2 to the third is not 2 times 3. It is 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. So be very careful there. I have a lot of students write 6. It is not 6. 2 to the third is 8. And then I have power to a power means multiply. And then I simplified that to get 8a to the 9th. The denominator didn't need any simplification, so I just left that. And then I did break it up into 8 divided by 2. That's the coefficients, is 4. And then I have subtraction here, 9 minus 6, because of the division. And I get 3. So my final answer is 4a to the third. So here, if you wanted to, I did mention it verbally, but this did come from 2a to the third to the third. Oh, got ahead of myself. And then that went to here. So if you wanted to write that out, you could, if that helps you for your notes. But that's how you would do that. Just be very careful with those coefficients. That's normally where students get tripped up. Okay, and then these last two, I didn't put 2. I put 1, but I'll add 1. Spoiler, I'll add 1. Okay, it's not 1 more, it's 2 more. So this one has to do with a negative exponent. So when you simplify an exponential expression, if you end up with a negative exponent, it's going to tell you that it is not completely simplified. And so what happens here is that when you have a negative exponent, what that actually means is that it's in the denominator. So when it's I said that weird, you can convert it to being in the denominator. And here's why. This one here is a disguised exponent. So it doesn't look like an exponent, but it actually is. And this is the second property that I wanted to talk about to explain that. So there's a rule here that anything to the 0 power is 1. That's a property. So it has to do, it's a long story. It has to do with place value, but for this lesson, I won't get into that because it is detailed. I do have it in another video, so you can go look for that, but I don't want to make this video too long. So anyway, the property is that anything to the 0 power is 1. So x to the 0, 100 to the 0, 1,000,000 to the 0, anything raised to the 0 power is 1. So what's actually happening here is this is a disguised exponent. If I were to have, sorry, I just get excited. I get giddy about this stuff because I think it's so neat. If I have this expression, I can actually rewrite it as a to the 0 because a to the 0 is 1, right? And then I can use my properties, subtract those, and that is where that negative exponent comes from. So I don't want you to have to like memorize things in mathematics. If you know where they come from, then you can see that process in your mind and you're not memorizing this. You know where it comes from because 1 is a to the 0 or whatever to the 0. And then we can use our properties to subtract, and that's that negative exponent. So all that to say, when you have a negative exponent in an expression, if you move it over the fraction bar, either to the top or to the bottom, it changes it to a positive exponent. So that sounds really weird, but go with me on that. That is just how it translates because of this property there. I hate not talking about it because I hate not giving you pertinent information, but a negative exponent is indicating a fraction number or a decimal number. It just comes from place value. So like 10 to the first is the tens position, 10 to the 0 is the ones position, 10 to the negative 1 is the tenths position. So I told you I wouldn't get into it, but I did anyway. I just hate not giving you information. So that's where that comes from. Again, I have a different video on that if you want to look for it, but let's look at this example here. I have a negative exponent right here. Let's pretend like, actually, I'll just write it out. If I had a problem, x to the 7th and y to the 1st over x to the 3rd and y to the 4th. And then I simplify that and I get 7 minus 3 and 1 minus 4. That's where that negative exponent is coming from. So if you come across a homework problem where you're ending up with that negative exponent, if you throw it to the denominator, it becomes positive. So when you simplify this expression, if you put it in the denominator, if you flip it over that fraction bar, wherever it is, it changes the sign of the exponent and it becomes a positive exponent. Because we know based on the property that y to the negative 3rd is the same as 1 over y to the 3rd, because remember this is y to the 0 and it all translates, it all equals. And so that's why I just kind of shorthand and say, oh, you just throw it over the fraction bar. But the math behind it is this stuff here. The shorthand language of it is, oh, just throw it under the fraction bar and it becomes positive. It's not magic, it's mathematical. It's just, you can kind of, I use simple language to kind of explain that stuff. So those are your two other properties. We have our simple properties where if you're multiplying components with the same base, you are actually adding exponents. If you're dividing components with the same base, you're actually subtracting exponents. If you have power raised to a power, you are multiplying exponents. And then the last two properties are the negative exponent. If you put it under the fraction bar or move it over the fraction bar, it changes the sign. And that is partly because anything to the 0 power is 1. So that is all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I will see you in the next one.